Hello, let's learn applications of Pythagoras theorem.
Number 1. In acute angled triangle, if in a triangle ABC, angle ABC is less than 90 degree, AD perpendicular BC such that B dash D dash C, then AC square equals AB square plus BC square minus twice of BC into BD. Okay, this statement we are going to prove. In a solution of this statement, as per the situation, we are interested with a triangle in which angle ABC is less than 90 degree. Okay, let's consider such a triangle ABC in which angle ABC is less than 90 degree, means it is acute angled triangle. Since AD perpendicular BC such that B dash D dash C, means it is definitely acute angled triangle. Now let's mention given and what to prove. Given in triangle ABC, angle ABC is less than 90 degree, then AD perpendicular BC such that B dash D dash C, then means consequent part, that consequent part is to prove. Then what? AC square equals AB square plus BC square minus twice of BC into BD. Okay. Now if you observe a diagram carefully, due to say AD perpendicular BC, triangle ABC is divided into triangles and each triangle is a right angled triangle. Okay, and we know that if triangle is right angled triangle, we can apply Pythagoras theorem. Let's write a proof. In a triangle ADB, angle ADB equals 90 degree, and therefore angle ADB equals 90 degree, side opposite to right angle is a hypotenuse, and according to Pythagoras theorem, hypotenuse square equals sum of the squares of right sides. Means here, therefore AB square equals AD square plus BD square. Let's call it as equation first by Pythagoras theorem. By Pythagoras theorem. Okay. Similarly, in a triangle ADC, angle ADC equals 90 degree. Angle ADC equals 90 degree, and therefore we can apply Pythagoras. AC square equals AD square plus DC square. Therefore AC square equals AD square plus DC square by Pythagoras theorem. Okay, now you may note DC is a part of BC. DC is a part of BC. Since BD plus DC equals BC, we can write DC equals BC minus BD. Okay, at the place of DC we are going to write BC minus BD. As DC square is here, we are going to write BC minus BD. BC minus BD its square. Since what? B dash D dash C. Okay, and rest of the terms will be as it is, AD square as it is and AC square is also as it is. Okay, because we are interested to prove that AC square equals AD square plus BC square minus twice of BC into BD. But according to Pythagoras, we have just AC square equals AD square plus BC square. Instead of that AD square plus DC square, we want AB square plus BC square minus twice of BC into BD. Means we are going to convert that result in terms of AB and BC. That's why we replaced DC as BC minus BD. Okay, now therefore again we may write AC square equals AD square plus BC minus BD bracket square. It is in a form of A minus B bracket square. And we know that expansion of A minus B bracket square is A square minus 2AB plus B square. And that's why according to that identity we can write BC square minus twice of BC into BD plus BD square. Okay, dash dash dash, since we have A minus B bracket square equals A square minus 2AB plus B square. Okay, using this identity we have an expansion. Now let's rearrange this equation as what? AD square as it is. Let's bring close that plus BD square. Okay, BD square plus BC square as it is minus twice of BC into BD again as it is. Okay, now AD square plus BD square. Already we have AD square plus BD square as what? AB square. Let's put there equals AB square plus this BC square as it is minus twice of BC into BD dash dash from 1, and therefore we have a result AC square equals AB square plus BC square minus twice of BC into BD. Okay, this is substitution for AD square plus BD square. That substitution is AB square from equation 1. Hence the proof. Now let's see second application. In obtuse angled triangle. Okay, if in a triangle ABC angle ABC is greater than 90 degree, AD perpendicular BC such that D dash B dash C, then AC square equals AB square plus BC square plus twice of BC into BD. Okay, same thing we have to prove, but instead of that minus, here is plus. Okay, now let's give it solution. According to this statement, we need a right angle triangle. Not a right angle triangle, we need obtuse angle triangle. Let us suppose triangle ABC is obtuse at vertex B and seg AD perpendicular to BC such that D dash B dash C. We are going to write an equation for AC square as what? AC square equals AB square plus BC square plus twice of BC into BD. Okay, now let's split given information in given and to prove. Okay, antecedent part is given, consequent part is to prove. That's why given in a triangle ABC angle ABC is greater than 90 degree, AD perpendicular BC such that D dash B dash C. Then to prove, what to prove? AC square equals AB square plus BC square plus twice of BC into BD. Okay. Now let's write a proof. Due to seg AD perpendicular line BC, we have two right angle triangles. Triangle ADB is right at vertex D and triangle ADC is also right at vertex D. That's why we can apply Pythagoras theorem to those right angled triangles. Okay, and therefore first of all let's talk about triangle ADB. In a triangle ADB, angle ADB equals 90 degree and therefore AB is the hypotenuse, AD and DB are remaining two sides and therefore by Pythagoras we can write AB square equals AD square plus DB square, equation first, by Pythagoras theorem. Okay. Similarly, in a triangle ADC, angle ADC equals 90 degree. Angle ADC equals 90 degree. Okay, angle ADC equals 90 degree and therefore AC is the hypotenuse. AD and DC are right sides. Therefore, AC square equals AD square plus DC square by Pythagoras theorem. Okay, we have a result AC square equals AD square plus DC square. But we want to prove AC square equals AB square plus BC square plus twice of BC into BD. Means we want right side in terms of AB, BC and BD. But we have it is in terms of AD and DC. But DC is made up of DB and BC. Okay. That's why let's write that DC as DB plus BC. Okay, equals AD square as it is. DC we are going to write as DB plus BC. It's square because there is DC square. Since D dash B dash C. Okay. And that is equals AD square plus, now it is in a form of A plus B bracket square. And we know that A plus B bracket square equals A square plus 2AB plus B square. Applying that identity, we can write DB square plus twice of DB into BC plus BC square. Since A plus B bracket square equals A square plus 2AB plus B square. Okay. Now AD square plus DB square is AB square. Let's write it as AB square plus twice of DB into BC plus BC square from 1, and to get a result as AC square equals AB square plus BC square plus twice of BC into BD. Let's rearrange. Right side equals AB square plus BC square plus twice of DB into BC. We can write twice of BC into BD. And therefore AC square equals AB square plus BC square plus twice of BC into BD. This is an application of Pythagoras theorem in a case of obtuse angled triangle. Number 3, Apollonious theorem. Apollonious theorem. According to this theorem, if in a triangle ABC, M is midpoint of BC, then AB square plus AC square equals 2AM square plus 2BM square. Okay, this statement we are going to prove. Let's see a solution. Let's consider any triangle ABC. Let us suppose it is triangle ABC, in which M is a midpoint of BC. Okay, let's suppose it is M, which is midpoint of BC. Say AM is a median. Okay, let's mention in given, in a triangle ABC, M is midpoint of BC. To prove, what to prove? To prove AB square plus AC square equals 2AM square plus 2BM square. Okay. Now, if you observe diagram carefully, as M is a midpoint of seg BC, seg AM is a median. Okay. And due to this median AM, triangle ABC is divided into triangles, triangle AMB and triangle AMC. Okay. And if you observe angle AMB, it is acute angle. Similarly, angle AMC is obtuse angle. And we learned applications of Pythagoras theorem in a case of acute angle triangle and in a case of obtuse angle triangle. And according to that applications, we used to write an equation for side opposite to acute angle and side opposite to obtuse angle. Okay, and for that we need perpendicular again. Okay, means acute angle we divided into right angle triangles and obtuse angle triangle we divided in two right triangles. Okay, now for that let's mention in a proof. Let seg AD perpendicular side BC such that B dash D dash M dash C. Okay, AD perpendicular BC such that B dash D dash M dash C. Okay, and therefore from figure, what's from figure? In a triangle AMB, angle AMB is less than 90 degree. AD perpendicular BM such that B dash D dash M, and therefore square of side opposite to acute angle means what? AB square equals sum of the squares of remaining two sides, means AM square plus BM square minus twice of on which side perpendicular is drawn means twice of BM into a part of that side adjacent to acute angle and right angle, that is DM. Let's call it as equation first. Since application of Pythagoras theorem in a case of acute angle triangle, similarly in a triangle AMC, angle AMC is greater than 90 degree, means it is obtuse angle triangle. Okay, then AD perpendicular MC such that D dash M dash C, D dash M dash C, and therefore by application of Pythagoras theorem, square of a side opposite to obtuse angle, angle AMC is obtuse angle and side AC opposite to that obtuse angle, therefore that AC square equals sum of the squares of remaining two sides, means AM square plus MC square plus twice of a side on which perpendicular is drawn, means MC into a part adjacent to that obtuse angle and foot of the perpendicular, that is DM. Okay, what's that? DM. Since application of Pythagoras theorem, now BM and MC are equal because M is midpoint of BC. That's why we may replace that MC as BM. Okay, let's replace MC as BM, keeping rest of terms as it is, AM square as it is, but MC we are going to write as BM. That's why MC square, it will be BM square plus twice of BM into DM dash dash dash. Since BM equals MC, okay, since M is midpoint of BC, okay, let's call it as equation second. Therefore AC square equals, now adding equations 1 and 2, adding equations 1 and 2. What is equation 1? Equation 1 is AB square equals AM square plus BM square minus twice of BM into DM, and equation 2 is AC square equals AM square plus BM square plus twice of BM into DM, and we are going to add these two equations, and therefore at the left of equal sign there will be AB square plus AC square. At right side AM square plus AM square gives us 2AM square plus BM square plus BM square gives us 2BM square, and minus 2BM into DM plus 2BM into DM will cancel each other. Okay, and therefore we have a result AB square plus AC square equals 2AM square plus 2BM square. This is known as Apollonious theorem. Okay, Apollonious theorem we may state as, if in triangle ABC say AM is a median, then AB square plus AC square equals 2AM square plus 2BM square. Thank you.